Yeah, so back in the first release of DOCSIS 4.0, we started talking about it with really FDX, um, and then with ESD coming on board. FDX is probably somewhere in a year and ahead of ESD from our deployment perspective and what I've worked with. Um, it's probably worth adding. We have over 30,000 nodes deployed in FDX today in DOCSIS 4.0 in the industry. So we have some experience there. Is my key. But when we go back to the start and we look at DOCSIS 4.0 and that technology, they released the technology being designed. The chipset working with Broadcom was just released to 5 vendors, or five service providers. And when you think about that, that's pretty tightening down. And then as the networks grow and the competition grows, because that's what's happened to us and consolidation. Can't forget some consolidation in the networks as well. And that technology was under a joint development agreement with the end user or the service provider and chip manufacturer Broadcom. So you had FDX flavor and you had an ESD FDD flavor with extended spectrum going all the way out to 1.8 gig with a forward spectrum of 5 to 684. And then of course when you look at the FDX, you're talking about overlap from that forward on the forward spectrum, and you're able to transmit and receive over that same spectrum with TDMA. So that technology was something that we've been working on and have deployed and have experience with, and a lot with the ecosystem, supporting the ecosystem. So when we're talking with Broadcom, and I actually had calls with them from time to time, I support that B2B relationship with them, and so we have calls, and I was talking to some of the guys. I'm like, man, what are you guys trying to do? Single-handedly kill the cable industry? And what do you mean? What do you mean? I was like, well, your competition, your regional providers can't get the same technology, so you're kind of forcing the regional cable guys to have to look to other technologies, which is PON, which is fiber to the home. And so I was really glad to see on this year, on September the 25th of SETE Expo 2024, that they released a new flavor of DOCSIS 4, which is called Unified. And they released it for nodes, amplifiers, and modems. So that opened the industry up for the regional guys as well as the big guys, and an ability to move their networks forward with cable and not having to do a migration or an overbuild themselves. So at that same time, Max Linear, who's another partner that we work with, released their Puma 8 cable modem chipset that would allow you to do DOCSIS 4 for the cable modem only. So again, moving technology forward, offering better speeds, being able to do symmetrical speeds, those kind of things were opened up to the whole market, which is, for me, it was very rewarding to see.
There's a lot in there, right? Having been at Expo this year and hearing a lot of the buzz around, unified DOCSIS 4 and some of the announcements from, Broadcom and Max Linear, it is an interesting time and place to be in the business, right? There was a whole alphabet soup of stuff that you mentioned at the beginning: FDX, FDD, ESD, B2B, PON. So I know we have some slides that we want to kind of talk to that hopefully will help clarify. When we say ESD and FDD, we're really talking about the same thing, right? One is the extended spectrum DOCSIS deployment in DOCSIS 4, which is still frequency division diplexed, which is different than full duplex DOCSIS or FDX. And then the other thing that you mentioned was the JDA, or the Joint Development Agreements, with those 5 MSOs or operators that you mentioned. Well, we actually didn't mention who the operators are, but they're the big 5, and I'm sure you can guess probably, those first 5 pretty easily. Because when you look at the amount of subscribers that those 5 have, it's in the hundreds of millions, right?
Absolutely.
So it's enabling the big MSOs to begin to develop with the same vendors, using the same silicon and the same core as in the nodes and amplifiers and cable modems, and then choose how you want to use it, whether you want to do a frequency division diplexed ultra high split or high split, or do a full duplex DOCSIS, or some combination of the two. It's going to be really interesting what the agreement will enable us to do as operators. So really wanted to just talk about today, like, what's possible, like what is in DOCSIS 4, and how is Harmonic thinking about that technology with their products, whether it be your cable OS or your nodes, and some of the strategies that are enabled within the DOCSIS 4 protocols that maybe Harmonic is looking to deploy to its customers.
Yeah, the core, as I always like to talk about, well, when I talk about DOCSIS 4 with some of our customers, things of that nature, DOCSIS 4 is doing a lot more of what we already do. So that's how I describe it, kind of in layman's term. But, we're doing OFDMs, we're doing OFDMAs, we're doing, just dynamic bonding groups, so, and then we add on some really cool features that are kind of like, when you think about ISM or something like that, we use, being able to do, sorry, I said that wrong. You have to scratch that one too, sorry. But when we talk about PMA and advanced technologies like that, and being able to do that on a V core, we have the capabilities of doing it actually on the core itself, opposed to having an external, PMA engine. So when you talk about that kind of technology where you're looking at noise in the upstream or noise in the downstream, and actually building exclusion groups and doing that without any human intervention, are the technologies that we're doing today, and is already built within our virtual core that we've built, and we are about 96% of the market in that virtual space. So we've got a ton of experience there. It's the only reason to say that. A ton of growth. We've been there, done it. We have support as part of Cable Labs to be able to support other vendors as they to us, but the secret sauce is still there. Nobody gives up the secret sauce, right? What makes us better than the other, or whatever, anybody better than anybody else. But you look at the really 3 operational modes of the unified DOCSIS being like FDX, support, on a single chip, and actually being able to go all the way to 1.8 with that FDX, not just to stop at 1.2 like we do in today's world of the first chipset release of FDX. So, and then we got FDD, ESD. It's called both 2 people call it 2 different things, as you do. Extended spectrum is what most people kind of old term. I think it came out first, and then they came up with this dynamic diplexer. So. But all that aside, it's still going up to, doing your high split or an ultra high split up to 684 on the upside, and downstream all the way to 1.8. The cool thing with the unified RPD and the RPD chipset, from our perspective, our RPD will be auto switching. So there'll be one RPD supporting 3 technologies, and we can get into maybe later, talk a little bit about Flex FDD. and what we're doing there, which we demoed, by the way, live at Expo. We did it with a couple of customers, and we did it in our own booth. So it was very, very cool, very enjoyable. The speeds and stuff are off the charts. When you start talking about DOCSIS 4, and you're really talking about some really high speed technology, like being able to do 8 OFDMs, 3 OFDMAs at a high split, being able to do 13 gig down and do 1.5 gig up. Or, another configuration might be just an ultra high split at 396 and being able to do 11 gig and 3 gig down, or 11 gig down, 3 gig up. And then even getting, if you get into the ultra high split at 684, you can get speeds of 9 gig and 6 gig. So those are some really cool things that you're able to do.
So it's so funny that we run right past this. I mean, like, let's be honest. We're talking about over coax.
Yes.
Right?
Absolutely.
And a decade ago, if somebody would have said, hey, you're going to be able to do symmetrical gigabit speeds over coax, they would have got laughed out of the room, honestly, because that was PON land, and only in 10 gig PON deployments would you even be able to conceive of symmetrical speeds in the multi-gig kind of realm. And so here we are in 2024, late 2024, post Expo. And we're talking about these different DOCSIS 4 deployment types, and there are some enablers to that, though. Like, let's get in the weeds here a little bit, because for years and years we were limited in our signal quality by our analog optical links and the length of your link and your link loss budgets and your hardware and your optimization and NPR curves. And so there was always this ceiling of how good a signal quality you could deploy into your HFC network. And then along comes DAA. We're just going to throw out all of the acronyms today, right? Yeah, I think we might as well. So distributed access architectures and your remote PHY devices, whether it's remote PHY or remote MAC-PHY, where now you have these incredible signal quality generating devices where your downstream signal quality is in the range of like 50 dB MER, which was unheard of. And in the upstream, it's north of 40. I've seen them as high as 46 SNR. Absolutely. On the upstream. So that technology then enables this really high signal quality, which allows us to deliver really high order modulation channels like the OFDMs and OFDMAs that you mentioned at 4K QAM. Heck, they're even talking about 8K QAM across super wide bandwidths, right?
Yeah, you think about that, and you think about your subcarrier spacing or something being at 25 kilohertz or 50 kilohertz. You think about on the downstream on the OFDM being able to do 6. I mean, this is lab. When you look at the constellation, this is lab spec, right? But being able to do 16.384, and you're talking about just within that one OFDM at 1684, you're doing 2 gig, 2.2 gig. So those it's very much there. We can do that in a lab condition, but I will tell you, in the real world, we are actually truly seeing plant good enough to run 496 or 8192 on that and be pretty consistent about it. Of course, when you add frequency hopping and frequency ranging of the modems and stuff, and it can move itself around, not to go, too way deep in that, but there's things like that we do. So if your signal level's up, you got a better modulation profile. If your signal level's down, then you got a little bit less frequency, but you still have good throughput from the IP or through the network or from the bandwidth perspective of the IP traffic. So we're even talking about 4096 on the upstream. So you start thinking about that, and that's a gig per OFDMA.
Yeah, you mentioned PMA earlier in passing, and profile management applications. I actually wrote a paper on this year. They've become an operational imperative, right? Because the one thing that They absolutely have. And if anybody's not deploying PMA, I would encourage you to strongly reconsider, because the one thing that we know about the HFC plant is that it's pretty dynamic, right? It's subject to a lot of environmental harsh conditions, ingress, spurious, transient signals.
LTE is probably the worst deviant in the market. So anybody that has a cell phone, they're in that LTE space and they're creating noise for us that we have to take care of.
Yeah. And the great thing about PMA though is it's so dynamic, to your point. Like the LTE stuff aside, which is pretty persistent in over the air, broadcast. But there's a bunch of other noise sources that would be spurious and, just come and go. And these agile profile management applications can say, hey, there's an impairment. I'm going to mitigate it, downgrade my mini slot profiles to something a little more robust for a period of time that the impairment persists, and then go, oh yeah, it's all good now. Like, let's go back to a higher order modulation, and your throughput goes up. And it's really more about mitigating the impact to the customers than anything else, because they'll never feel it. And oh, by the way, from an operations guy, that means I don't have to roll a truck to go fix that temporary spurious thing, because the software did it for me. And then when the noise went away, it normalized everything to the optimal throughput and profiles. And so it's magical, but to the point where the core and the architecture has such a huge upside, right? With signal quality and the higher order modulations, that now our ceiling just went way, way up because of all of the other technology behind it.
Yeah, the other piece of that people haven't got a glimpse of yet, which is very, very key, is building a core, a virtual core, that we have a disaggregated virtual core that allows us to run multi-applications. We call it multi-tendency, because we can run DOCSIS, we can run PON, we can run B&B virtual BNG technologies. We can run PMA technology right on the core. So what really and the analytical data. There's two things that we do that I've been part of that is revolutionary in our industry. Number one is our analytical data and what we collect on a per second basis. We're not talking about waiting until tomorrow to figure out what happened. We're talking about figuring out what happened right now. Which is very cool on our analytics. But when you think about collecting all that information, well, we know what the MER is. So we know before we already collect the receive MER. We know what the OFDM profiles are. We already manage that. So we can do that on the virtual core as a technology that is totally dynamic. Not going out to some SNMP polls, even though we use the same type technology to pull the information back from the modem, we still have that killer capability of actually looking at that, receive MER and going, hey guy, let's adjust that modem and let's build an exclusion band at this frequency, and we'll notify the customer in our analytical data and say, hey, you got an issue. So wherever we push that information, whether it be in your manager of managers or whatever, you flag that, you can send a technician out, go fix that. And then when he gets done, there's no human intervention. We just put it back to the original state or the maximized state. And then we got max throughput. So, and that takes the modem out of the equation. We don't care what modem it is. It could be a 3.0 modem, 3.1, 4.0. We don't care. So that's pretty neat stuff when you talk about virtual cores and where the virtual core can actually take you from that aspect.
So there was a couple other things I want to drill into there that you kind of glossed over. The VBNG or ROLT, you can now take your node housing and put a PON OLT in it. And so you can service your HFC customers with multi-gig symmetrical HFC services. And oh, by the way, you can launch a PON circuit from the same box, which is pretty awesome. So we'll come back to that one. But the other thing that you mentioned is the telemetry. Like, my company does use your products as well. I can send technicians out to nodes and say, hey, the module retainer screws on this RPD are loose. And I can tell you that without opening the lid.
Absolutely.
Because we get temperature in different places inside the housing where we can say, hey, it's an RF tray that's loose, or it's an RPD module that's loose. Oh, by the way, we think we have a failing SFP because our optical voltage bias is fluctuating. Oh, and we can see our transmit and receive levels all the time. Like, there's so much telemetry. If you're not using it and consuming it and building tooling that can infer how your network is performing, again, I will urge you to strongly reconsider, because there's so much information that's available from the box and from the core that is useful to describing how your network is performing. So, all right, run with that one.
So, it's very funny. We kind of look at this and we talk about it and all the cool stuff, but that's so overlooked by the industry. You'll hear people say, well, you can only do 160 service groups on a cluster. You can only do 300 gig or whatever. But it's even more than that, because I know what bandwidth and I know what bit rate and I know what the performance is. And we start reporting those things with time that allows the plant operations people or your ops guys to be able to make decisions. Hey, this node's running at 80% on the downstream, on the upstream. Let's figure out, should we do a node split? Should we migrate to another node? Should we put a PON port in, which, like you said, is so easy to do. I mean, the software is multi-tenancy. We already support it. If you start with DOCSIS, for instance, you throw a PON port out there, you can do what we call a brownfield edge out. So instead of running more copper, you're on the edge, you got a node sitting there, you can service a small campus of whether it be a college campus, we have people doing that, or hospitality or hotel or anything, and you're offering those gigabit speeds. It's just another medium to us, which is very cool. And to watch that technology grow and mature, and then the things we keep adding on with those kind of technologies is very cool. But we monitor some 40 billion service points in a given 24-hour period of time, and we with what we call our COS Central. And not just trying to give an idea of what we do, and how the technology that allows us to collect these points, and be able to tell, like you said, the temperature, not only just the temperature of an RFP, a power supply failed, someone opened it's something as simple as somebody opened the node. And to me, one of the biggest things is what we've used in technology called last gasp. Our last gasp functionality, man, that node loses commercial power. You don't have to roll the truck. We're going to tell you the commercial power went out, and we're going to tell you that the commercial power came back on. And as we've matured and as the market matured, we actually do proactive things like we have with our Insight technology, where we're actually taking all this information, and I always say you can get data overload very easy. But if you start building insights and going, hey, I got a service group out here, and let's make it simple. Customer A is really hogging all the bandwidth in that MAC domain or that service group. You can make a decision on what to do with that guy. Maybe you move him to PON. I don't know. Maybe you do a node split. Maybe you put him on a smaller MAC domain. A lot of different decisions you can make because of our technology and because we're monitoring it. But we start telling you about it before it's a problem. You probably have 6 months before you have to really make a hard decision. But it gives you that time as a operations guy to look at it and go, oh, look, we got something going on. Let's watch this. Same thing with like looking at we do things like FEC, MERV, just not to mix IP and RF, but we're getting into the weeds with what's going on on every piece of the network. I like the fact that you talked about the just even looking at the life cycle of an optical SFP. That probably tells most granular part of the story, because that's that's the level we get to monitor things, and that's very not just the user, but also the serviceability that we allow the service provider to have is amazing.
So you started speaking my love language there when you started talking about spectral efficiency and MER and packet loss, because those things are really interrelated, and I think they're super important in today's networks with profile management applications and some of the flexibility that's contained in these networks. Not just the profile management itself, but the bonding groups that you mentioned, having flexible bonding groups and switchable diplexes. Like we can talk about Flex FDD, but before we even get to that, there used to be a pretty linear relationship between your capacity in your service group and the size of your node, where now we're seeing super users that are consuming a bunch of bandwidth, right? So we have that flexibility to say, hey, do we want to offload that to PON to preserve the HFC bonding group or MAC domain? But even within that, if you see capacity start to drift up, the first thing that you can look at is, what's your spectral efficiency? Do I have impairments that's resulting in downgraded profiles, which is great for the customer because they don't see the packet loss and feel the impact of it. But the lower modulation orders in your OFDM and OFDMA mini slots mean that you can't transmit as many packets, right? So your capacity actually goes up. So we're really looking at that spectral efficiency, saying, first things first, if I see a service group that has low spectral efficiency, the question is why? Is it utilization? Is it the number of users? Or is it an impairment that's resulting in lower order modulations? Now we fix that, right? You can send a technician and go fix your LTE ingress. Now all of a sudden your profile management applications go back up to 4K QAM and your capacity actually goes down.
Absolutely.
So who'd have thunk it that if you just do some, network maintenance repairs, you can gain capacity, but that's the world that we live in now.